Let us look at proposition number 44 of Works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says the volume of any sector of a sphere is equal to a cone whose base is equal to the surface of the segment of the sphere included in the sphere and whose height is equal to the radius of the sphere. So let's take it step by step. Let the solid of revolution of the arc L, A, L prime, lowercase, be a sector of a sphere. What the proposition is saying is that the volume of the sector of this sphere is equal to a cone with base equal to the surface of the segment of the sphere and height equal to radius of the sphere. So now let R be that cone. Which cone? Let R be the cone that has as its base equal to the surface of the segment of the sphere and height equal to radius of the sphere. Let S be the volume of the sector OLAL prime. What the proposition is saying is that R is equal to S. Now we are going to use proof by contradiction. So if S is not equal to R, then S is either greater than R or less than R. So let's take it one by one. If possible, let S be greater than R. Find two straight lines beta and gamma such that beta is greater than gamma and beta is to gamma is less than S is to R. Let delta and epsilon be two arithmetic means between beta and gamma. Now, LAL prime is a segment of a great circle of the sphere. Join OL and OL prime. Circumscribe and inscribe polygons of 2n equal sides to the segment of the circle such that AB is to AB is less than beta is to delta. Revolve the polygons with the segment of the circle about OAA. Once we have done that, we know that volume of the circumscribed solid, let's say capital B, is to volume of the inscribed solid, let's say lowercase b, is equal to AB cube is to AB cube. We have seen this in a previous proposition. Now, which means AB cube is to AB cube is less than beta cube is to delta cube, which in turn means, remember, beta, delta, epsilon and gamma are in continued proportion. So that means AB cube is to AB cube is less than beta is to gamma, which in turn means AB cube is to AB cube is less than S is to R. Capital B plus cone OLL prime is greater than S. We know that. Remember, this is the circumscribed solid plus the cone is greater than the volume of the sector, which implies, because of this proportionality, that lowercase v, which is the inscribed solid, plus cone O lowercase l prime is also greater than R, which is impossible because an inscribed solid volume plus the cone OLL prime cannot be greater than the figure in which it is inscribed. So therefore, S is not greater than R. Now, let's take the second case. If possible, let S be less than R. We saw S greater than R. So now we look at S is less than R. Again, find two straight lines beta and gamma such that beta is greater than gamma and beta is to gamma is less than R is to S. And we follow the same steps like we did here. Circumscribe, inscribe polygons of 2n equal sides to the segment of the circle such that AB is to AB is less than beta is to delta. Revolve the polygons with the segment of the circle about OAA. Then volume of the circumscribed solid B is to volume of the inscribed solid B is equal to AB cube is to AB cube. Again, all these steps are common, which means AB cube is to AB cube is less than R is to S. We know that V plus cone OLL prime is less than S. Inscribed solid plus the cone is less than the volume of the sector, which implies that the volume of the circumscribed solid plus cone OLL prime is less than R as well, which is again impossible because the volume of a circumscribed solid cannot be less than the figure on which it is circumscribed. So therefore, S is not less than R. So S is not greater than R and S is not less than R, which means S is equal to R, which in turn means that the volume of the sector of the sphere is equal to a cone with base equal to surface of the segment of the sphere and height equal to radius of the sphere. So that is proposition number 44 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. And by the way, this is the last proposition of this book. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now. Bye.